Walk down into the cellar of an old farmhouse on the worst afternoon in August, the kind of day where the upstairs bedrooms are unbearable and the air outside feels like a wet blanket. And something strange happens about 4 steps down. The air changes. It goes cool and still and heavy, and it stays that way whether it is August or January, whether the sun is blazing or the yard is under 2 feet of snow. That cellar is not insulated. Nobody is paying to cool it. It sits at roughly the same temperature every single day of the year. And the reason why is the single most useful thing an old farmhouse can teach you about staying cool. Here is what those families did with that discovery. And here is what almost nobody does with it now. They put their food down there. Root cellars, spring houses, milk houses built over cold water, the whole system of keeping a family fed through a northern year was built on the fact that the ground a few feet down holds a steady temperature no matter what the weather does above it. They moved the food to the cool ground. What almost nobody does, then or now, is the obvious next step, which is to move the air instead. My name is Walter Northwood, and by the end of this, you will know exactly why the ground under your feet sits at the same temperature year-round, and what that temperature actually is. How a buried pipe turns that fact into cooling for a house without a compressor or a drop of refrigerant, why old farmhouse families were already using this physics every single day without a word for it, and the honest reason almost nobody builds one today, which is not a conspiracy and is not what the internet will tell you. It is one specific failure that ruins these systems, and I am going to tell you exactly what it is. Start with the temperature, because everything else follows from it. Go down past the frost line, which in the northern states and the Prairie provinces runs somewhere between 4 and 6 feet, and the ground stops caring what season it is. Down at that depth and below, soil temperature settles into a range of roughly 50 to 55 degrees Fahrenheit, and stays there year-round, through every heat wave and every cold snap. Not because anything is heating or cooling it, but because dirt is slow. It takes so long for surface temperature swings to work their way down that by the time summer's heat reaches that depth, it is already winter up top, and the two cancel each other out. That is the whole secret. The ground is a flywheel so large that the seasons average themselves out inside it. Old farmhouse families did not have a name for this, but they built their entire food system on it. A root cellar dug into a hillside or under the house exploited exactly that below frostline constant, holding somewhere in the 30s to low 40s in a well-built one, cold enough to slow spoilage, but never cold enough to freeze what was stored there. Almost every farmstead in early New England had one. A spring house worked the same way from a different direction, using water coming out of the ground at around 55 degrees. To keep milk and butter and cream cold in a stone trough through the hottest part of summer. These were not quaint, they were infrastructure, and they worked because the ground does not have seasons the way the air does. Here is the step that almost never got taken. If you can put food into that 55-degree ground, you can also put air into it. Run a pipe underground, deep enough to be in that stable zone, pull outside air in through one end, and by the time that air comes out the other end into your house, it has given up most of its heat to the soil around the pipe. In winter, the same pipe runs in reverse, with frigid outside air picking up warmth on its way through. The engineers call this an earth tube, or an earth-to-air heat exchanger, or a ground-coupled heat exchanger. In parts of Europe, they call it a Canadian well or a Provençal well. There is no compressor, no refrigerant, no chemistry. A blower to move the air is the only powered part in the entire system. And for a northern house specifically, the winter side of this is arguably the more interesting half, even though every video you see about it is filmed in August. Think about what happens on a morning when it is 10 below zero outside. Every cubic foot of fresh air your house takes in through the vents, through the gaps, through whatever ventilation you have, arrives at 10 below, and your furnace has to lift all of it up to living temperature. Run that same air through a buried pipe first, and it arrives somewhere in the 40s instead. Your furnace is no longer starting from 10 below. It is starting from 45. And the ground did that work for nothing. That is a far larger temperature gap than anything the same pipe accomplishes on a summer afternoon, which is why in a cold climate the heating benefit tends to outrun the cooling benefit, and why it is a little strange that this always gets sold as a summer trick. The materials are genuinely cheap relative to what they replace. Smooth-walled pipe, a trench, and a fan. That is the whole parts list, and it is why every video you have ever seen on this subject leads with a dollar figure. What those videos leave out is the part that decides whether the thing works or poisons your air. And that brings me to the honest answer about why almost nobody builds one of these. It is not banned, it is not suppressed. Nobody made it illegal. And if a video tells you a government agency buried this, they are making that up. The real reason is less dramatic and much more useful to you. Warm, humid summer air hitting a pipe that sits at 55 degrees does exactly what warm, humid air always does when it touches something cold. It condenses. Water forms on the inside walls of that buried pipe, and if there is no way for that water to get out, it pools. A pipe with standing water in it, in the dark, at a comfortable temperature, collecting the dust and pollen that came in with the air, is close to a perfect environment for mold. This is not theoretical. Across Europe over the last couple of decades, earth tube installations that were built without proper drainage did precisely this, pooling condensate through the summer, growing mold inside the tube, and then delivering that air straight into the house. The system that was supposed to make the air better made it considerably worse. There is a second concern worth naming plainly. In areas with naturally occurring radon in the soil, a leaking or poorly sealed buried pipe can pull radon-bearing soil gas into the airstream. A properly sealed tube does not do this, and a well-ventilated house is generally better off than a sealed one. But it is a real consideration, and it deserves a real radon test rather than a shrug. And then there is the plainest reason of all, the one that has nothing to do with risk. Digging is expensive. A trench 4 to 6 feet deep and long enough to matter costs real money and equipment. And the honest assessment from building science people who have studied installed systems is that the energy savings often do not justify that installation cost on their own. It supplements a heating and cooling system. It does not replace one. That is a hard sell for a contractor and an easy thing for a homeowner to skip, and that, far more than any cover-up, is why these are rare. So who should actually consider one? If you are already excavating, that changes the math completely. A new build, a foundation replacement, a septic or utility trench going in anyway, any project where the machine is already on site and the ground is already open, is the moment this stops being a boondoggle and starts being cheap. The pipe going in during an excavation you were paying for regardless costs a fraction of digging for the pipe alone. If you do it, the design details are not optional, and every one of them exists because of the condensation problem. The pipe has to be sloped continuously so that any water that forms runs to a low point rather than sitting in a belly in the middle of the run. That low point needs an actual drain or a condensate sump you can service, not just a hope. The interior needs to be smooth-walled rather than corrugated, because corrugation traps water in every ridge and makes the whole thing impossible to clean. It needs to be sealed at every joint, both against soil gas and against groundwater. And you need physical access to inspect and clean the inside, which means clean-out ports, because a pipe you cannot inspect is a pipe you are trusting blindly for the next 30 years. Get the slope and the drain right, and the mold problem largely goes away. Get them wrong, and no amount of good intentions saves it. There is a smaller version of this idea that costs nothing, and that plenty of old farmhouses used without ever digging a new trench. If you already have a cellar or an unheated basement that stays cool through the summer, and most old northern houses do, that space is already sitting in the stable ground temperature. Opening the cellar door and letting a fan move that cool air up into the main floor on the hottest afternoons is the same physics with none of the excavation. It is limited, it depends on the cellar being genuinely dry, and it will not cool a whole house. But it is free, it is available today, and it is much closer to what those families were actually doing than any buried pipe. What strikes me about all of this is that the farmhouse families were not missing anything. They understood the ground held a steady temperature, and they built their whole food economy on it. They just applied it to the problem that would kill them first, which was keeping food from spoiling, not keeping bedrooms comfortable in August. Comfort came second when survival came first. We inherited the comfort problem, and cheap electricity solved it for us before anyone got around to burying the pipe. If you have got an old cellar that stays cool all summer, tell me in the comments how cold it actually gets down there and what part of the country you are in, because I would like to see the range. And if anyone watching has actually built an earth tube, I especially want to hear whether you dealt with condensation and how. Subscribe if you want to keep seeing what these old places got right and what they simply never got around to. And if you are the kind of person who would rather understand why something works than be told it is a secret, stay close because the ground under an old farmhouse has more in it than one buried pipe.